Morning guys, today's presentation is about the IConfiguration pattern and practice, choo-choo, which is really an implementation of the strategy pattern. In fact, it is the strategy pattern. And this is a very easy way to understand the principles behind the strategy pattern. And then I'll sort of progress into the strategy pattern and the major benefits of using that. But I think the easiest way to start this presentation, different to all the rest, is just jumping straight into the code. So this is the problem sample I've put together, and really there's a few things I'm trying to highlight here. So we're trying to use an in-memory cache provider, and the in-memory cache provider, this is hard-coded within the program itself. So for example, if I had a large application, there'd be references to instantiate the in-memory cache provider, and this object is potentially going to be defined multiple times. And the fact that we've got different parameters here, this object itself takes a different set of parameters depending on how you want to configure it. So there's the potential again that not only are we initializing this object in different places, but the parameters may change, and for different use cases of the cache provider, maybe there wants to be a different set of configuration. I mean, these are common sort of problems, specifically the latter, that there needs to be a bit of customization for a specific use case. But basically the points I'm trying to make here again are that we have primitive properties that we're passing in to configure the larger object that then can be defined multiple times. So just to show you that I still have some coding ability in me, my in-memory cache provider, I add a string and I get the string back out. Choo-choo! So jumping back to the presentation, what I'm coining the IConfiguration pattern, in fact it's not something I've coined, it's been around for quite a while, is a way of managing instantiation of an object and managing different configurations for that object in a maintainable way. So for me, the S.O.L.I.D pattern with a request and response object is quite an easy way to work. The ability to add new properties into a request or response object, and then that's more based in your model sort of business logic, is a lot easier to work with for me than having a shed load of different different constructor overrides or different method overrides as well for different parameter options. So one of the benefits of the IConfiguration pattern, and again I'll go into the code and go through this a bit further, but now you've seen the problem, is that if we have a pattern that manages configuration, we can inject a different configuration pattern at runtime. So for example, in the cache provider settings, maybe that the machine I'm running locally doesn't have a lot of resources, so the maximum number of entries in that cache list would want to be capped so that I don't run out of resources on my local machine. Again, potentially UAT, there needs to be a set number of, a finite number of objects that can be cached because of the similar sort of issue. Live, however, maybe that it's spread over different servers. That value is going to be significantly higher, hopefully, and the potential there that on the event that it's reached, maybe you want to send an email out, or so on and so forth. So that's a very, very specific and simple case of how I might want to configure my cache provider object depending on the environment it's going to. There are obviously different ways we might want to configure it in the same environment. For example, there might be business logic where we might want to swap between one cache provider and another when there's been a failure, or the endpoint's not reachable. That's more sort of business logic, but the ability to swap in that configuration at runtime is really what this pattern's about. The other benefit of this is that with the IConfiguration pattern, there's the ability to specify a base class. So again, going back to the cache provider option, we might want to have an in-memory cache, a SQL Server cache, a mem cache or elastic cache, however you want to say it. And for those three cache providers, there's going to want to be a few common components there. One, the time span that the object wants to live for in the cache. Two, the endpoint that it's going to connect to pass information. Specifically to that for the two latter points. The first one maybe not so much. The in-memory cache provider, depending on how it's defined. But generally, it's good practice to have some sort of endpoint where you're sending your data. And three, potentially the maximum number of objects you're willing to store, or the size of the complete cache of objects. So this is a very simple example. I've just gone with an integer, but again, you know, these sort of common values are inherent to the majority of cache providers and other objects that have a lot of commonality. So there are There's a strongly typed way of using the IConfiguration pattern, which is where I very much tend to lean, and that's where we have an interface for configuration, a base abstract class, and then specific implementations where providers need extra information to work. So I mean, for example, SQL session state or a SQL cache may require a username and password, the others may not. It could be argued that that should be in the IConfiguration. I have an example of this, so I'll not go into too much details of how I've worked around this, and that's basically IConfiguration pattern within the IConfiguration pattern. But we can get to that. The other benefit of IConfiguration is the ability to easily extend. You don't have to worry about adding new parameters or overloads and then having to go back and change your code. It's just an interface, and it's just a class that's managed through a factory pattern. So again, this is really how I've solved a lot of the problems really well and had it work for a majority of the amount of time without any issues. Everyone's got a different opinion, there's lots of different approaches, but one of the benefits with this pattern as well is that it lends itself easily to work with the configuration element in the web or the app config. So because we have a concrete configuration class, that can be extrapolated into the configuration section of your app or web config, and again loaded in at runtime. So that there can be multiple definitions in there if, for example, you want to swap out providers on a whim, or more likely through business logic where one cache provider's failed and we have a backup just to make sure that the system runs within acceptable parameters. And then finally, there are different ways to do this, and there's a few ways. Like I said, my preferred way is to have an interface, a base, and then specific configuration implementations. However, if that doesn't make sense and there's not a lot of commonality, then maybe there's just multiple interfaces to separate out those specific bits. So for example, another approach to what I'm going to show you shortly with the credentials for the SQL Server username and password, that could be an interface which is iCredentials. Not in the base, but as an entry onto the configuration, and therefore anything that inherits that interface must implement those properties. I'll jump back into the code again, and I'll show an example of the strategy pattern at work. So this time I'm basically going to create cache provider, and create cache provider, as I'm sure you've noticed, is basically a factory pattern where I have a cache type, a limit, expiration, and address. So while this isn't particularly using the configuration pattern, in fact that's the next example, this is more specifically the strategy pattern itself, where we've basically taken the different cache providers, in this case in-memory cache and SQL Server, and we've wrapped them in an iCache provider interface. So we have the ability to specify the type of cache provider we're after, and then the properties that relate to them. And as you can see, following on from the previous example, we have a limit, expiration, and now we have an address, because SQL Server requires the address, however the in-memory cache provider does not. So already we've got the factory pattern, which is great. We're working towards more maintainable and sustainable code. We're able to dynamically return a cache provider depending on some sort of configuration element, whether that's defined at runtime or a web config entry, it doesn't really matter. The ability to swap them out is really what's key, and then the bits of information to make it work. So here again we've just got a cache object, we add it into the provider just here, and then we get it out and then spit out the information. So as I alluded to, the actual type of the cache provider is returned from the app config. So hopefully, if I haven't missed too much, good, there's an entry for cache type, and then the enum value representing that. So quite easily, through the app config in this case, we can swap out in-memory cache provider for the SQL Server cache provider, like that. And again, job done. So this is absolutely cracking. If we've got a live website, it's running slowly. Obviously, whenever doing anything with caching, we don't want to hook in everything and have it fail. We want to have some sort of graceful redundancy plan. So, for example, put in the cache. If it's not there, then go back to the database. So everything still works. We just take a performance hit. If that's the case, then we've got the opportunity by using the strategy pattern to go into the app config and then when the site's running low because the in-memory cache provider, there's not enough RAM on the server, we can then swap out from in-memory cache to SQL Server. We've not got to make a massive code change, providing we follow the pattern correctly and we have the correct configuration, which, as you can see here, we do. We pass in these primitive values, and then job done. So, and my colleague's homesick today. Hope he's getting better, or I hope he feels better today. So that's an example of the strategy pattern. Basically, we're injecting the logic we want to use at runtime based on either business logic or defined logic. So, jumping back into the presentation again, the strategy pattern and the programmer's evolution. I'm very, very much in favor of design patterns. They make our lives so much easier, and they're there for a reason. You know, that they've been around for quite a while, and the S.O.L.I.D principle is definitely something that we should all be aware of. And in case you don't know, S.O.L.I.D is single responsibility, open, closed, list of, substitution, interface segregation, and dependency inversion. And I'm not going to say that again because it's probably not going to happen. It's basically a set of principles that help development run smoothly. What I'll do now is jump into the last example, which is the strategy pattern with the IConfiguration sample. So this is, again, each of these samples are building iteratively on each other. So the first one, again, had a very specific problem where we instantiate a cache provider in the code, and we, at that point in time, pass the properties we need to instantiate that object. The next example, we're now using or leveraging the strategy pattern where we're using a factory to create a concrete type of the cache provider, and based on an app config configuration, we're then specifying that type. So we're using two patterns here, but the final example is how I feel the two patterns being strategy factory and IConfiguration, which really does fall on the strategy pattern, can be used to really leverage a lot of cleverness within the code. So we have an ISMS provider here. This really should be done through IOC and DI. The reason I haven't done it here is for simplicity, but the idea being that you have an interface defined, use IOC, DI, and then you have a factory to return that type of concrete, or you work with your IOC, DI to resolve the implementation either based on the app config or business logic, etc., etc. So again, I've completely ignored those two concepts to make this very, very simple. But that's really where, if I was to do a fourth example, where we'd be going. So we have an ISMS provider, and I've got a board of caching now. I'm cached up to my arse, so I want to send a few SMSs out. So again, I've got three SMS providers. Clickatel, choo choo, burst SMS and SMS broadcast, and I have a factory. It's a very simple factory. It looks at the type, and now we're starting to see the IConfiguration pattern come into case. So I'll start with the simplest example here. We've got Clickatel, and if I type equals Clickatel, we will, if formatted correctly, return the Clickatel SMS provider, which inherits from the base SMS provider and ISMS provider. So the base provider is an abstract class which has the IConfiguration interface defined, and then whenever instantiating anything inheriting from the base SMS provider, you must specify a configuration. So we're setting a concrete contract, if you will. We're saying that we must specify a configuration for this provider to work, and that configuration must, as a bare minimum, have defined, in this case at least, an endpoint and a set of credentials. So all of the SMS providers in this sample require credentials. However, those credentials differ depending on the provider. So this is when I said I've got the IConfiguration pattern within the IConfiguration pattern, which is effectively the IConfiguration and iCredentials, if that makes sense. So in case of authentication, all of the providers require a username and password. So great, we can share that logic, define it once, happy days. I'll move into how that's been defined for the other provider that requires something extra a little bit later. I don't want to digress too much from the core viewpoint of the providers themselves. So we have a configuration, we pass it in. Clickatel, in this example, will take a quick look at the endpoint. If it's not been defined, then it will define it itself. So this is really just a nice to have, and to show that we can have these concrete values stored in the class itself, and they don't need to be in the app or web config. Personally, I prefer not to have a shared load of information in the web.config. If this is indeed a static string, it's not going to change. There's no redirect URLs. Then I'm all for the fact of having it as a constant, which this should quite probably be in the class itself. So we, as with factory pattern, we create an instance of Clickatel SMS provider, and we have a base configuration, which funny enough inherits from the IConfiguration, and defines the endpoint and credentials. So as we have the endpoint defined in Clickatel, all we need to do is get the credentials, which at this point in time I pull out from the app settings and just return a set of base credentials. So hopefully you can see here that the iCredentials themselves, and then the base credentials is something that inherits from them and defines the username and password. So in the instance where we have a provider that requires slightly more information, slightly more credentials, we can implement a new class which allows us to then specify API key or so on and so forth. But again, I'll get to that sort of slightly later. So that's Clickatel, that'll go through, and then because we're using the iSMS provider, we have the ability to send an SMS, and then we have an iMessage. You guys can pretty much see where this is going. It's a little bit extra work. However, the benefits in this case, before you get too detracted with the fact that there's more work for developers, is that we can easily swap out every SMS provider and send a message through all of them. So a message itself comprises of data from and to. There's again a nuance with burst SMS, which is to do with credentials, which we alluded to earlier, where it's time sensitive and requires SHA encryption. SMS broadcast, again, is slightly different to the two, and we've got the ability to reply to messages. So we can see that we've got this ability to send an SMS through these three providers, and they differ slightly. One offers more functionality, this one here, and this one requires more authentication. So we've got the ability to wrap this wrap these calls, swap them out at runtime, and again, like I said with the caching provider, SMS exactly the same thing. We'd have business logic where we want to use Clickatel because it's one of the cheapest. If we get a run of failures in our factory pattern here, we can capture the number of failures that each of these providers returns, and if it reaches a business threshold limit where we've had 5 failures in a minute, what we'll do is we'll swap over to Burst SMS, who has no failures. Again, we're tracking the failures between all of them. So we've got the ability to swap out and then make sure that we're not losing the sort of SLAs that we're after. So going into the Burst SMS, I have a Burst SMS configuration, and then we have Burst SMS credentials. So here we can see that Burst SMS credentials has a salt, and that's required for the SHA-1 encryption. So the pattern being that we have implementation from the base configuration because we want access to the endpoint and the credentials. But in this case, we want to override the credentials, hence the fact that we say new with the Burst SMS credentials, which again inherit from this but have salt. And then in reality, I should have put this in the app configuration as well, but for now, if I put numlock on, we'll put 1, 2, 3, 4, 5, 6, 7, 8, 9, which if I remember is the correct salt for this example. And finally, the create provider SMS broadcast, which has slightly more functionality. So SMS broadcast, we have the same application configuration settings as Clickatel. However, in the SMS broadcast configuration, we have something slightly different where we enable reply to. And again, this example is quite specific of what I'm trying to show, but the business logic can be defined anywhere, and this can work slightly differently. So in the enable reply to, I've set the ability to use it always to true, because by using this provider, I want to have people have the ability to reply to SMSs. If it's not a requirement, I use click-to-tell, which is slightly cheaper, for example. And that again, instantiate this, credentials, job done. So again, going back to this example, we've got the providers, we've got the different credentials types, different authentication, different functionality. And by virtue of the fact that I'm using the strategy pattern, the configuration pattern, and the factory pattern, I can easily instantiate these values, use them via the interface, send them off, and if we run this, we'll see that we've encrypted account using S.O.L.I.D 123457889, send, and that's the burst SMS send, and then we've got the SMS broadcast. Just turn notifications off. Hopefully no one else is sick today. So jumping back to the presentation now, we're coming to the end. I'm sorry to keep you all so long. Strategy pattern. There are a few benefits. We talked about S.O.L.I.D, which is good. It's again a way to vary operations or algorithms independently from the clients that use it. So, like I said, a good example of that is the SMS provider. If one goes down, the ability to plug another one in. Again, that's your plug and play at runtime, and then the complex business logic can use a state machine, for example, with the SMS providers when they're working and not working, from cheapest to most expensive. Or alternatively, if your message has high priority, then maybe it should be sent through another provider where there's read receipts that cost a little bit more. Again, there's the ability to share common logic and extend quite easily. So you've seen how the code's been extended to have the base configuration, the base set of credentials, which are common for all three of the SMS providers. And then in the specific case, we need to use SHA-1 encryption with Assault. We inherit from that class and add in our new Assault parameter. And then with the ability to enable reply tos, that's an extension on the functionality. And again, just we add that in and retain the base offering that we have. So it's so easy to have the base offering, extend it, and if we find more functionality common to all of them, add it in at the top, and then they've all got access to it. And personally, I hope you guys have seen the same thing. Code is a lot easier to maintain. It's a lot easier to understand and see what's going on, see what information is required. And you know, we saw this work through the factory pattern where it's coded in the code itself. It could be the app config, it could be pulled from a JSON file. It doesn't really matter. The key point is that we can do this and we provide the ability to do it. So thank you very much, everyone. I hope I haven't bored you too much today, and have a good Friday. Cheers. Bye-bye.